Alright, let's solve the 11th day of AoC in HolyC. Let's go. Uwu. Day 11, Dumbo Octopus. You enter a large cavern full of rare bioluminescent Dumbo octopuses. Wait, is it gonna be too loud? It's probably gonna be too loud. Okay. Oh, that's so cute. Look at that. It's actually super cute. I really like that. Is that like whatever they added in the latest Minecraft? Yeah, the glowing... Oh, it's a glowing squid. It's not a glowing octopus. Okay, whatever. They seem to not like the Christmas lights on your submarine, so you turn them off for now. There are 100 octopuses arranged neatly in 10 by 10 grid. Okay. Each octopus slowly gains energy over time and flashes brightly for a moment when its energy is full. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of the light will happen. Each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus, your puzzle input. For example, okay, so here are the things. Cool. The energy level of each octopus is a value between 0 and 9. Here, the top left octopus has an energy 5, the bottom right has an energy 6. Okay, that's cool. You can model the energy levels and flashes of light in steps. During a single step, the following occurs. First, the energy level of each octopus increases by 1. Then, any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including the octopuses that are diagonally adjacent. I hope I pronounced that word correctly. If this causes an octopus to have an energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having their energy level increased beyond 9. An octopus can only flash at most once per step. Can only flash at most once per step. Okay. Okay, I see. Finally, any octopuses that flashed during this step has its energy level set to 0 as it's used all of its energy to flash. Adjacent flashes can cause an octopus to flash on a step even if it begins that step with very little energy. Adjacent flashes can cause an octopus to flash on a step even if it begins that... Okay, I see. Consider the middle octopus with the energy 1 in this situation. Alright. So, okay, flashbang situation. After step 1, okay, all of them flashed. Okay, so I see what's going on. After step 2, alright, an octopus is highlighted when it flashed during the given step. Here's how the larger, during the given step, here's how larger example above progresses. Okay, so this is basically how it goes. And then they flash. Okay, so that's cool. So let me see, then they reset to 0 when they flash, and then, okay, so I see how it goes. Cool. This is actually really fun. Okay, so, but what's the problem? What we have to solve here? After step 10, there have been a total of 204 flashes. I suppose the proof of solution is going to be the amount of flashes. Fast forwarding here is the same configuration every 10 steps. Oh my god. Ooh, here is this. Oh, it's the same configuration. Okay. Cool. After 100 steps, there have been a total of 1,656 flashes. Given the starting energy levels of the Dumbo octopuses in your cavern, simulate 100 steps. How many total flashes are there after 100 steps? Okay, cool. This sounds pretty straightforward. You just simulate the process. But I'm a little bit nervous about part 2. So, like, the thing that made me nervous about part 2 is the configuration after 10 steps phrase, which made me think that maybe in a part 2 we'll have to maybe find the cycle or something like that. Yeah, so I don't know what's gonna be the part 2, right? But maybe it's gonna be having something with cycles, right? So after each step, for example, the whole configuration just repeats itself. Right, so, and it's gonna be super hard, and I just like usually hate these kind of problems, but we'll see how it goes. So maybe we just need to implement this thing. So I suppose it's always 10 by 10, so my puzzle input is always gonna be 10 by 10, so there's nothing to worry about in here, which is nice. Nice. So let's go. So I need to maybe start my thing. Right, starting. And let me close the chat, of course. So AoC 2021. All right. So I'm gonna run AoC 2021. Okay, then. So yeah, new day 11. Right, so this is going to be new day 11, and in here, yeah, so I need to come up with something that will automatically load the inputs and the samples at some point, so I don't have to do this kind of stuff anymore. Right, AoC. Okay, so MNT home, AoC 11 and stuff like that. So I think I forgot to actually start my TeamUX. I think it's quite important. Though it is usually better to start TeamUX somewhere like somewhere here, because it usually remembers its current working directory. Right, so I'd rather do that here. Home AoC 11 AD sample txt, and I'm gonna insert. So this is our sample, right? Okay, so this is the sample that we're using. Okay, and then I'm gonna open the input txt or something like that. Where is my input? Get your puzzle input. Save. Oh shit, I forgot to do that. And then I need to save that and quit that. And if I open the input txt, it accidentally inserted these things, so I can easily remove them. Okay, so now let me run AoC, and we're gonna be ready to start coding. How about that? We are ready to start coding. So here's that, here's that. So what are we going to do? We know for a fact it's 10 by 10, so maybe I'm gonna just define this constant n, which is the size of the board, right? So let's call an array that stores the energy level something like octa, right? So they're going to be n by n octas. Right, so and initially it's going to be filled with 0, but maybe it doesn't matter. Maybe we're going to actually set them to particular values when we read everything. Okay, so now I can start reading things line by line. So the size greater than 0, right? In the previous episode, we implemented a very cool thing that allows me to chop by a particular delimiter, right? So I can provide the string, right? Then I can define the delimiter. In our case, the delimiter is a new line, and then I need to provide the output, right? So I'm going to provide the line as an output. There we go. So maybe I need to allocate it in here. So, and what I want to do in here is essentially iterate through each individual character of that line, right, and assign it to octa, right? So, and basically also convert it from a character to an integer. So we also need to keep track of the like rows and columns and stuff like that. So let's actually define something like row, column. Right, so, and initially, as far as I can tell, a row is going to be 0, right? A row is going to be 0, and here we do the following thing. It's going to be column. Though I wish there was some sort of assert, so I could assert that the line size is equal exactly 10. Right, but unfortunately asserts like literally don't work in TempleOS. We already actually confirmed that, right? So we cannot do assert false. Right, so missing something, yeah, it doesn't like that, I think. Compiler parsing assert. There is an compile time assert, which doesn't really make much sense, in my opinion. Just a second. Okay, so assert failed. Right, so assert fails, but is it a runtime assert? Like, I'm not really sure. So, for instance, if I define a variable x equal to 69, right, and then I do assert x equal to 69, right, is it gonna... Okay, so it worked. X equal to 420, right, and assert failed. Okay, this is really, really weird. Oh, it also says something about comma. Right, so that means you can do something like assert x equal 420, and you can put some sort of a message in here. Can you put a message in? Yeah, I can put a message in here. This is really, really weird. Just a second. Control-Alt-G, and I can't see shit in here. So that's how you use asserts, apparently. Right. And it's also a runtime assert. This is such a weird syntax for assert. Why does it have a hash in front of it? So I would assume that anything that has a hash in front of it means that it's a compile time thing. But apparently it's run... Like, I can never understand Terry, to be fair. Like, it is really, really weird. But anyway... So, just a second. It doesn't work. Control-Alt-G, and I need to... Yeah, there we go. So I'm really sorry that it took some time to actually discover that, because, like, I like to have asserts in my, you know, in my code. Like, it just makes it, like, a little bit... How to say that? I keep worrying about incorrect data all the time. So for the peace of mind, yes, I remembered what I wanted to say. For the peace of mind, I wanted just to have that. Right, and can I say something like, it was also assert failed. I don't understand Terry. Terry is like really weird. Have a really weird language, I mean. Okay, so what if I put a message in here? So, and then it's gonna be 0, column, less than 10. Right, and then I can do the following thing where I do octa. Right, so then I do octa equal to row and then to column. And then I can do line begin equal to column minus 0 or something like that. So let me quickly do that. Incorrect line size. And so in here, I also want to put the following thing. Row. You know what? I think I can do a for loop in here. I think I can do a for loop. I think I can do a for loop. Row equals 0, row less than n. Right. And then I'm just gonna do a row. It has to be something like this. Assert. A row has to be SV. I really don't know what I'm doing, to be fair. Let's actually go back. Swiss size greater than 0, so this is going to be that, and then it's going to be row plus plus. Okay, so if I try to compile this entire thing, it is still complaining about something, so this is going to be 22. So something about not having a particular identifier, I'm not sure. Is that because of the assert? I don't quite understand. What does it want from me? So SV line, is that because of the chop by delimiter? I'm pretty sure. Oh shit, I remember this shit. Yes. This is because I moved this thing to the common module, off screen, so I need to fetch that thing from the repo. So let me quickly do that. So, but that means that during synchronization, I'm gonna lose everything there. So I need to copy paste the 11th day. Oh my god. Okay, so AoC 2021, right? So, and I need to copy MNT home AoC 2021. 11, right? So I'm gonna copy this entire thing and I'm gonna just like put it in here just in case. Right, I need to fetch the latest stuff here. I completely forgot about this thing, I'm sorry. Git merge origin master. Right, so and the thing I need to do, I need to sync that into the temple, AoC 2021. Right, so and if I don't do that properly, it could have actually removed my my thing in there, so it's kind of bad. Okay, so I'm gonna move 11 into MNT, AoC, home, AoC, like so. I also want to do this kind of stuff. All right, so I'm gonna run AoC one more time. Okay. So let me see. Okay. So now I should be able to compile this entire thing. There we go. So I finally managed to compile that. It was hard, but I managed to do that. So let me actually implement a function that basically prints octa, right? So print octa, and I'm gonna do it like that. I64 row column for row equals 0, row less than n, plus row. For column equals 0, columns less than n, plus column, and so what do we want to do in here? We want to like print a single number, right? So this is going to be a single number, octa row column, right? And we also have to put some sort of like a new line in here. So this is going to be a new line. So after we read all of that, I can just do something like print octa, and there we go. So here is the entire thing. So that's fine. Okay, we can now try to implement something like next octa, right? Next octa. And what it will do, it will basically calculate the next state of the octopuses. Next octa. And we probably want to separate everything by a new line super quick. And then we're going to print octa one more time. There we go. So how are we going to do that? So there is like one step. One step. Just a second, we've got something. Zozi, why don't you give more cores to TempleOS? You don't trust Divine Intellect multi-core? Thank you so much, Isleo, for 100 bits. I never actually needed more cores in TempleOS, so that's why, essentially. If I ever will need more than one core while solving this entire thing, I will probably add more cores. So it's not like me trusting or not trusting, it's just like I'm using pretty much the default configuration of QEMA because I never needed to change anything, so... Thank you for 100 bits. Thank you. Okay, so there we go. For row 0, row n, plus row. For column equals 0, column less than n, plus column. So, and I suppose, I think I can try to simulate this stuff directly, right? So essentially I'm going to do octa row. So not directly in place, that's what I meant, right? So I think I can do that in place. And so essentially, if after that, so when do we start flashing? When do we start flashing? When we have 9 and there's a lot of scrolling here involved. Then any octopus with an energy level greater than 9 flashes. Okay, that's actually pretty cool. So if octa row column is greater than 9, it needs to flash and probably reset to 0, right? But during the flashing, we probably need to iterate through all of the neighbors of that octopus and also increment their thing by 1. Which is rather interesting because, yeah, that may actually trigger a very interesting reaction that you already sort of like handled the neighbor octopus, right? And then you went to the next one and I probably need to draw that. So this is actually very interesting. Just a second. So there could be like a very interesting chain reaction that you wouldn't really expect to happen, but it may happen. So you have to be super careful with this kind of stuff. So essentially, if we are iterating left to right, top, bottom, right? So we basically handled all of these things, and then we handled this thing, right? And this thing flashed, which caused something that we already bypassed to flash again. And basically we have to sort of backtrack to things that we already looked at, which may cause a thing to flash in here and so on and so forth, right? So it's sort of like it's yet another DFS, I suppose, right? It's yet another DFS situation. Yeah, kind of, isn't it? Right. So one of the things we can probably do is... Yeah, that's actually pretty cool. It's actually pretty cool. Maybe we need a DFS, or maybe not. So maybe I need to also make a small break because, yeah, because for some reason I'm a little bit nervous right now, so I need like a very small break. So, all right. I've got a cool idea actually for this entire thing. So essentially we can just increment everything by 1, like so. And since the size of the board is actually rather small, we can keep like iterating the board over and over again, handling the flashes, right? So until the whole process sort of stabilizes, if you know what I'm talking about, right? So it will actually simplify it quite greatly, I think. So after we increment everything by 1, we can just iterate one more time the whole thing. And if something increased more than 9, we can flash it, and that will update like neighbor things. We can go again and do another flash and another flash until there will be no flashes at all, until the whole thing sort of stabilized. So again, we can do that because the size of the board is rather small. So I think it's a pretty cool idea. So I'm going to do it like this. A row equal a row less than 1, right? And plus row, and there we go, for column 0, column less than n, plus column. And here, if octo row and column is greater than 9, this is a flash, right? So this is a flash, and we have to do something about that. First of all, we probably need to reset octo row and column to 0, right? So we need to reset it to 0, and we also need to iterate through all of the neighbors and increment them by 1. Right. So, interestingly enough, we also need to keep track of how many flashes has happened. So I think we can provide a pointer to some sort of like a counter, like flashes, right? And we can increment that thing every time like a flash was detected. Flashes, I'm gonna do something like this, and I probably have to do it like that, plus. So how are we going to be iterating through all of the neighbors? Well, that's interesting. My usual trick of iterating through all of the neighbors is that, right, including the diagonals. So I actually show that trick multiple times. Right, so let me show you. Right. So you are located here, and here are all of your neighbors, right? So you can notice that you're basically dealing with the square 3 by 3. So what you can do, you can just iterate a square 3 by 3 and ignore the center cell. By doing that, you are iterating through all of the neighbors of that cell, including the diagonal ones. Right, you also have to check the boundaries and stuff like that, but it's like a little bit easier, I think, than hard coding everything or coming up with the array of all of the offsets and stuff like that. You just like do another nested loop and you just ignore the center. So yeah, so this is usually what I use, and I'm gonna do that in here as well. Okay, so but for that I'll need to have additional things in here. So I'm gonna call it d row and d column. Right, so and we're gonna do another thing in here for d row, starting from -1 up until 1, right? is going to be plus plus d row, then for d column minus 1, d column less equal than 1 plus plus d column. So this one is rather interesting. I'll need another variable and stuff like that, but maybe not. If d row not equal to 0 and or d column not equal to 0, we should consider them, because if both of them are equal to 0, that means it's the middle one. It's the middle thing. Okay, so now we need to take a look at the neighbor one, right? So we need to have something like n row. I'm going to call it n row as the neighbor one. So, and this is going to be row plus d row, and then we're going to have n column, column plus d column. There we go. And we need to check if they are in bounds. So if n row is this, right, and less than n, and the column is the same, so n column actually less than n, that means it is a neighbor that we can finally increment by 1. Right, there we go. So that means I can do something like octa and row and column plus plus. There we go. That was difficult. Right, there's a lot of code that involved in here, but we managed to do that. Cool. So we can probably maybe split some of these things to separate procedures, right? So that would kind of make sense, I think. Have something like flash, right? I'm gonna do it like this, flash, and it will basically accept like where it happened, row and column. And this entire thing is gonna basically, you know, iterate, do all of these iterations, so that maybe will afloat the next octa a little bit, because it's too much. And I can't easily... Yeah, so this text editor doesn't have a rectangular selection, I think. I think it doesn't have a rectangular selection, so I have to literally do this kind of stuff manually. Thank you, Terry, very cool. Right, so, and now I'm gonna do it like that, hopefully. There we go. This is so annoying, Terry. Why didn't you think about better text editor? Okay. All right, so here's the flashes, and then I can say something like flash row and columns. So you're basically flashing in here, and it will iterate through all of these things in here for you. So I would call this thing something like a row 0. Maybe it doesn't matter. Yeah, it doesn't matter, because I can just like allocate these things in here. I64, d row, d column, n row and column. Right, there we go. So I don't have to have d row and d column in here. Right, there we go. So I do a flash. Okay, and if I did any of the flashes, that means something got modified in here, and I'll have to do this entire thing yet again. Right, so let's have some sort of variable, something like stop, which is initially false, right? It is initially false, and I can say something like while not stop. We're gonna keep doing this entire thing. And of course, there is no easy way to indent a whole block. We have to do that again. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Thank you very much, Terry. Very cool. Okay, so, and when we stop the iteration, we're actually gonna set the stop to true. And if any of the flashes were detected, the stop actually says false. Right, so that means we continue doing this kind of thing. And that's basically it, I think. Right, so that's the whole process of the simulation. I really hope so. So let me try to see what's going to happen. Is it even compiling? So it's not compiling, so first we need to fix the compilation errors. So it's not liking this thing. Oh, because next octa actually accepts the flashes, right? So we need to do something like I64 flashes, which initially 0, and then we'll have to just provide this thing by the pointer. There we go, something has happened. I don't know if that's a correct thing to have in here, but I would rather to like test on this thing, if you know what I'm talking about, right? Because it's easy to see what the hell is going on in here. Right, so maybe I'm gonna actually like copy that thing to there, but it looks like, okay, so here's the 65 and 65, 37, right? 35, 67. We can try to take a look at some other stuff. Next, so I might as well copy paste this entire thing. So 88, 48, right? So 88, 48. So that looks more or less correct. And I can do another one. Right, so it's 01, 02, right. It's already incorrect, that's nice. So this is already freaking incorrect. So it's 00, but I have 01 for whatever reason, 01, 02. And yeah, that's a very interesting question, why it is like that. Right. So it could be something due to this one, all right? It could be something due to this one. But when something already flashed, here's an interesting question. When something already flashed, can it, can the nearby flashes increment it again? So we probably need to keep track of something that already flashed and basically don't flash it again, if that makes any sense. Because that's what it feels like, right? So that's what it feels like. Don't flash it again. So because of that, we may want to keep track of already flashed things. So yeah, so let me actually maybe read this thing one more time, a little bit careful. So first the energy level by 1, then any octopus with energy greater than increases the energy with all adjacent including octopus diagonally, also flashes. This continues as long as new octopuses keep having their energy level increase beyond 9. Octopus can only flash at most once per step. Okay, so well, that does not really explain much, but anyways. So okay, right, this thing like flashed and that thing flashed as well. So here's an interesting point. This thing flashed and this thing flashed as well, but flashing of this thing didn't increment anything in here. So that means we need to keep track of things that already flashed. So that's a good point, actually. Thank you for the example. I think it's very, very important. So flashed is going to be n by n, right? Something already flashed. So and this is basically where we can do something like this. Mem set flashed zero size of flashed. There we go. And so if the octopus is greater than 0, and I suppose didn't flash, but this is rather interesting. So I think we can add that check somewhere here, right? If something already flashed in here, we do not even increment it or do anything with it, right? So if flashed and row and column, if it didn't flash yet, we're incrementing it, right? So we're incrementing it, and there we go. If it's already flashed, we're not gonna even touch it. We're gonna just let it be. All right, so this is that. It becomes 0, and it also becomes flashed. Right, it also becomes flashed. So this is basically row, and this is the column, and it's gonna become true. Right, so it's gonna be flashed at that specific, step. So, and in here we have something interesting. Is it even close to what I was trying to, like, what we have in here? So it is kind of, yeah, it is. Actually, it is literally, okay, so I guessed that correctly. 59211, there we go. So yeah, that's cool, I think. I do think so. All right. So I'm more or less happy. Let me also double check everything just to make sure that nothing weird is going to happen. Right, so after something went flashed and was set to 0, it's never going to be modified by the nearby flashes. So that should be fine, I think. Okay, so, and we also keep track of all of that. Okay, so our goal is to simulate how many? Basically 100 steps, right? So we want to simulate 100 steps and just print how many flashes we've got. Let me remove this entire thing. For I equals 0, I less than 100, plus plus I, and I'm gonna just do next octa flashes, and then I'm going to just print that. So maybe it's gonna be part 1 d flashes. There we go. So if I take a look at that, it does not work. 81 because why? Because I don't have I, of course. Thank you so much for such a cool error message. And it's 1656. Okay, 1656. Okay, that makes sense. All right, so that's pretty POG, isn't it? I think it is in fact pretty POG. So let's take a look at the input. So that is sus, not gonna lie. What the fuck? Wait. 1656, 1656. 1615, 1615, 1615, is that correct? Apparently it is correct, okay. So we did it, we solved the part 1 first try, how about that? So let's do a committee, I suppose, and maybe then even a pushy. So git status, I actually want to sync all of that stuff into the host. I don't know why I got a little bit nervous at the beginning of the stream, because again, like I'm streaming every day at this point and it's like a little bit difficult for me. Okay, git status, git add home, right, so, and if I take a look at this thing, commit add day 11 part 1. Okay, I'm gonna push that right into the repo. Again, you can find the source code for my solutions in the description, and if you're watching live, you can find all of that right in the chat. I'm gonna quick paste this thing in the chat. All right, so let's go ahead and solve the part 2. Oh boy, oh boy. All right. It seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronized. Oh, okay. So, the example above, the first time all octopuses flash them. Oh shit! Isn't that like related to the one of the latest Veritasium videos? Do you guys remember that? I think it is inspired by the latest Veritasium video, one of the latest. Like Veritasium, because he literally made a video about that, and I think one of the examples was like fireflies. Right, so fireflies do a similar thing. This is so cool. Right, so something about synchronization, but I already forgot what was the thumbnail, and he keeps changing thumbnail. Yeah, the surprising secret of synchronization, this one. Yeah, I'm pretty sure this is where it got the inspiration, so I'm gonna copy paste it in here. Yeah, and for everyone who's watching here, so here's the thing. Veritasium video on synchronization. There we go. So probably what we need to do, we need to basically find after which point they start synchronizing. The first time all octopus flashes simultaneously is step 195. All right. You can calculate the exact, if you can calculate the exact moments when the octopus will flash, or all flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flash? All right, so let's go. I wonder if it's gonna be too much, too long to actually wait for that, but for this one it's not that much, it's like 195. Interestingly enough, for the part 2 we don't have to keep track of all of the things. Yeah, here is an interesting thing, we don't have to keep track of all of them. So that means, yeah, whatever. So I'm having too many thoughts running through my head right now, so it's kind of difficult for me to articulate. Okay, so let's go. So this is gonna be this one, and yeah. So the part two. Let me think. So maybe for the part 2, I want to extract read input, right? So that's probably what I want to do. So let's quickly do that. Read input like so. And so I'm just gonna copy paste this thing there. So we probably don't even need I here, but we do need I in here. So this is gonna be I, and here we're gonna just read the input. All right, so we read the input. Is it still working? It is not working anymore, because why? That was not helpful. Unused variable. Oh, this is just warning. 91. 91. Oh yeah, saved. Free saved begin. And is it gonna work? There we go, 1615. Cool. So now I'm gonna comment part 1 and then comment part 2, and we're going to read input. So what I'm thinking is we need to have this stuff and also flashes, right? Though for the flashes we don't really need to initialize everything with 0, right? While flashes not equal to n multiplied by n, right, we're gonna do the following thing. We're gonna set flashes to 0, and we're gonna do next octa flashes. If at any point, so the amount of flashes is going to be equal to the size of the board, they all flash simultaneously, that means we have to stop, and I think the part 2 is going to be basically that. So on top of that we may want to actually use for loop. Right, so this is going to be 0, if I understood correctly, unless there is a trick in here, right, and that is not going to work, right, because it's going to be too slow or something. Right, so let's actually go to the sample, right, so let's go to the sample and let's try to run this, and 195. So it's a little bit sus. It's a little bit sus, so let me take a look at that. So I'm gonna do that, and it's 249, 249, another gold star. Okay. So that's actually pretty cool. I actually liked this problem. I think it was kind of cool. Yeah. So even though it was simpler than some previous problems, especially like the digit thingy, I kind of enjoyed it more. Maybe because of the Veritasium reference, probably. I feel like this is a Veritasium reference. It must be the Veritasium reference, because it's a relatively new video, and maybe it was released at the time when he was actually like designing the puzzles and stuff like that. So it must be the Veritasium video reference. So yeah. So cool. That's pretty cool. I really like that. So let's do a committee and maybe even pushy. Oh yeah, visualization of this thing could be actually kind of cool. That's very interesting. So TempleOS has a built-in functionality to do graphics, and we streamed only for 1 hour. We have 1 hour left. We can try to use the built-in TempleOS functionality to do graphics, to visualize this problem. How about that? That's actually pretty cool. So let's actually do that. I really want to do that. Alright, so let's do something like sync, and we're gonna sync everything into the host. Right, so, and it's gonna be diff, so here is the diff. Yeah, that's pretty powerful. Git status, add home, commit, add day 11 part 2. Right, I'm gonna push that right into the repo. Push origin master. Push origin master. Okay, so, and I think I'm gonna do that maybe after a small break because I wanna refill my cup of tea. I wanna make a cup of tea, and yeah, so let's quickly make a break, and